So, welcome back all of you. We have now finished module 3 completely. We have discussed different aspects of stress path, which I feel and hope that it is sufficient for going on to the next or the last module on critical state soil mechanics. So, here in this lecture we will try to summarize what all we have learned in module 3. So, this module focuses on the stress path and its importance in soil mechanics, which I hope you would have appreciated by this time how important stress path is. Stress path helps to understand better the stress variations in the soil during loading and unloading and how the soil mass approaches failure. It gives a very clear representation, which we have tried to demonstrate in few of our lectures. This understanding helps to design the most suitable strength testing protocol. Now, if we do a kind of analysis prior to the actual deriving of the shear strength parameters, it also helps to understand how different sequence of loading that happens in the field would give different stress path. So, we can try to project or we can try to use the laboratory testing if it is possible, like stress path controlled triaxial testing. If it is possible, we can always do that in the lab to get the best representative shear strength parameters. So, it helps us in planning a suitable strength testing protocol. It would also help to plan the observation and instrumentation plan for monitoring the performance of the structure founded in soil. So, let us say that we are interested in doing some sort of monitoring. So, the stress path analysis in the beginning helps us to focus on what exactly and how and at what time we need to monitor. So, the instrumentation plan or sensors placement and its operation can be planned with the help of initial stress path analysis. Now, stress path representation in 3 different formats we have understood: sigma A, sigma R, TSS dash and QPP dash. Factors affecting total stress path and effective stress path has been discussed. Importance of failure line in stress path for both compression and extension we have understood, and we have also defined the failure lines for different cases, or different cases means the different stress path formats. Stress path for isotropic and one dimensional consolidation we have discussed. Stress path for unloading and reloading and the associated elastic behavior, because we are talking about the over consolidated state when we actually say it is unloaded. So, reloading also it follows the elastic behavior. Stress path for isotropic and anisotropic initial consolidation. So, the influence of K, like depending upon the initial K value, how it is going to change and where it actually gets placed, the initial, the starting point. So, we have discussed for both K not equal to 1 and K not less than 1, K not greater than 1. Elastic stress path for undrained triaxial compression, we have already seen that. Stress path for laboratory drain triaxial test for both compression and extension, we have discussed all the 4 cases with different permutation combination. Influence of initial stress state, that is in terms of K value, and what is the influence of cohesion on the stress path. We have seen that it gets extended above, so the available strength increases. Derivation of drained strength in TSS dash plot. Stress path for laboratory undrained triaxial test for both compression and extension, just similar to what we have discussed for drain test. But here A parameter, delta U determination and the uniqueness. So, ESP in undrained triaxial test is unique for identical soil specimen and initial state. Unique ESP irrespective of undrained compression or extension. Slope of undrained ESP and the role of Skempton's pore water pressure parameter A, we have seen that. Importance of effective stress path in defining the failure criterion. So, we have to keep in mind It is not the total stress path, it is the effective stress path for undrained case that determines failure. So, where the effective stress path touches the failure line, that is our point of failure. Derivation of undrained shear strength in TSS dash plot. Expression for undrained shear strength for initial isotropic condition, that is soil sample from the field, that is extension of this particular condition, where we know that due to sampling there will be initial pore water pressure of negative initial pore water pressure. So, since it is pore water pressure, it becomes isotropic condition, so it gets shifted to the isotropic line. So, it is a just modification of what is discussed in this. So, undrained stress path as a function of stress history. Lab effective stress path is identified for different field conditions. That was the last part of our lecture, where we discussed about how the stress path can be identified for various field conditions. So, total stress path and effective stress path discussed for various field situations like infinite slope, finite slope, excavation, shallow foundation, retaining wall supporting either excavation or filling. So, all these cases we have discussed. Now, to end this module 3, the major reference books that I have used for this module is Halls and others, J. Atkinson, R. H. G. Parry and M. Budu. All these reference textbooks are there in the reference list. If you want to know more or if you want to enhance your reading, you are free to do that, and these are the textbooks which I have referred a lot for developing this module. I have referred to others as well, but for basic textbooks you can refer to these. So, this is all for now. So, we have finished our module 3 and we are fully prepared now to move on to the next module and the last module, where we will discuss about critical state soil mechanics. So, thanks a lot for now. Okay.